Right, this video is about cumulative frequency charts. It's a very useful way of representing data and also gives us the ability to kind of draw out key statistics about data. If we look at this particular example here, a group of 60 students sat an algebra test and a geometry test. Each mark was marked out of 100. Okay, so we're just looking at one particular test in this example, and it gives us the ability to look kind of find out things as to sort of what mark was achieved by the top 10% of students. Um, 20% of the students failed. What was the fail mark? What was the median mark? That sort of thing. So let's have a look. This is the chart here. They very often have this sort of S shape here, which kind of indicates what's going on, which is most of the students are basically scoring in this middle bit here between sort of 40 and 70, something like that. And then fewer um, lower than that and higher than 70. So let us imagine that we've got these marks. All right, there's 60 students and they're all their marks are listed here in order. All right, so the way we're doing this basically is we're as we go from the first one, for instance, we would plot on here. So the first one would be the first vertically. We've got 60 students, so if we've got one small square up there and the cross, that corresponds to 4 there. That would give you 4 there, right there. Okay, and then 10, and then we've plotted all these all the way. And as we can see, we're finishing up here with the last few students scoring, 81 here. That would be what would that be the 56th student in sequence in order, and so on. So we've plotted all those on this cumulative chart here. Right, okay, so that's how do we use it? Well, for instance, the median. Let's have a look at the median. The median is the student with the middle mark. Now there's a 60 here, so in other exercises we might be wanting to take the midpoint of the 30th and the 31st. For the purpose of doing these, we're just going to stick to half of 60, so the 30th. So we're looking at what the 30th has, the 30th student in the in sort of ascending order has scored, and if we find that point and follow that down to the mark, it's going to be 48. And indeed, if we were to count up 30 on this list of numbers, I've not got the middle ones in here, but we'd find it was 48. How many students scored 70 or more? Well, 70th mark was was here. And if we look at all the students above that, 2, 3, 4, 5, 6, 7, 8, there'd be 8 students. Okay. Interquartile range. Well, we've got 60 students, so the lower quartile is the 25th percent the way through this set of numbers. So that would be the 15th student. And if we look along here to here and down, then we can look up the mark, which is 40. We do the same for the 45th, which is the 75th percentile, and that's going to give us 56. So the lower quartile is 40, the upper quartile is 56, to refer to the 25th and the 75th percentile as they of course, that kind of breaks the whole set of students into quarters, doesn't it? So the lower quartile is the 15th, the upper quartile is the 45th. So the difference between those two is 16. So the interquartile range is 16. Below 30 marks is a fail. How many failed? Well, we look up from there to there and across. Then we're going to see that in this bit here, there are seven students. Okay, so that is how we use this type of chart. Now, in this question, we have been given that curve to use and to interpret. We may sometimes have to build the curve ourselves. So if we look at this example here, then that is what we have to do here. Now we're told this problem is the cumulative frequency table gives information about the distance in kilometers that each of 80 workers travel from home to work in a certain office. Okay. Um, Now we haven't got the individual values here. We haven't got a list of 80 workers. Um, because quite honestly, dealing with a list of 80 gets a bit unwieldy, and then sometimes we're dealing with much larger numbers, thousands, in fact. So we want a method which actually is going to work when we've got very large numbers. 80 is big enough anyway. So what we would do in this situation is we would break it into categories. And we've broken it into these categories now because it's cumulative. We're basically sort of starting everything here at 0. So between 0 and 5, there are 17 workers whose distance traveled is between 0 and 5, sort of greater than 0, less than or equal to 5, 17. And then when we add in the ones that travel between 5 and 10 kilometers, well, we've got another 15. So that makes this row 32. That's the cumulative frequency. And again, yeah, we've got another 25 going in for this for 10 to 15 kilometers. So between 0 and 15 kilometers, we've got 57 and so on up till we've got the whole lot. All the workers are less than or equal to 30 kilometers. So that gives us this table with cumulative values. Now we can't plot all the 80, obviously, because we haven't got that information anymore. But what we can do is we can do some of them. So now what we're assuming now we don't actually know at this point whether or not the um, the 17th traveled 5 kilometers. That's an assumption we're making. We're sort of making an assumption that these 17 are spread evenly throughout that range of 0 to 5. So that's an important assumption. But as such, once we've made that assumption, what we can say then is, well, let's mark on that point. All right. So that's we're kind of seeing that the ones in between 0 and 5 kilometers, sort of are kind of somewhere along this stretch here, and then the 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 10 kilometer person that's going to be the 32nd. The 15 kilometer person going to be at 57. I'm going to go up to here. So that's there. 20th at 20 kilometers at 70. The 25 kilometer person is going to be at 76. And the 80th person is 30 kilometers there. So right, so we've got this shape here. Now we have to draw our curve in now, and we want to try and make it realistic. So it's going to be a sort of a. Let's just have another go at that. This one kind of doesn't look quite right. So I think if we're going to make this look realistic, we've kind of got to. All right. I mean, it could be. It could be that the shortest distance travel is 2 kilometers. No, no. But these are the points we've got, so we're kind of joining them up into a curve. This hasn't quite got the nice S shape that we had before, but it's near enough. Right, so there's the curve. Now we can just go ahead and answer the questions as before. Now the fact that we haven't got all the readings, or all 80 um, distances to work, we shouldn't let that stop us because basically, having put the line in, now what we're doing is we're kind of estimating those. So if it's not actually a dot, but somewhere along the line, then yeah, it's an estimate. We don't know, but that's what we're being asked to do. And it says here, usually you have to find an estimate for the median distance traveled. Well, the median is what the 40th person travels. So let's just kind of see if we can put that in. Let's use a different color. So here's a 40th, goes across to there, and then down to the kilometers. And what's that? That's pro looks like about 11, probably 11 kilometers there. Um, Interquartile range, yeah, we can do that. That's similar to before. So we're going to look up the 20th here. Find the value on the kilometer scale at the bottom, and the 60th it's going to be kind of there. So it's going to look that down there. So that looks like it's going to be uh, about 16. So I think we're looking at from 16 down to, what did I say here? 7. So that looks as if it's going to be 16 minus 7 will be 9. That will be the range. It'll be kilometers, of course, kilometers. All right, so that's basically what we would do if we were not given the curve, but we were given, the each category and the cumulative frequency. All right, so and again, we can answer all the other same sort of questions that we did before. Right, okay. Now, sort of fairly typical of this kind of problem is when um, we're given a table like this, but these are not cumulative. You will see here. This is just saying that there are six. This is cars. Okay, we've got 60 cars, and this first column is the number of miles per gallon that they do. All right. So we've got 6 cars that perform between 40 and 50 miles per gallon. We've got 16 that are between 50 and 60, 28 between 60 and 70, and 10 between 70 and 80. Pretty good fuel consumption, I think. So, and that's kind of generally the way the data is going to be presented to you. So this is much more typical kind of problem, thinking about what you might see in exams and so on. Right, okay. So what we're going to do? Well, what we have to do is we have to build the cumulative categories and the cumulative frequency. So if we take these first two, um, this is the cumulative category. So this would be 40 to 50. That's the lowest. Then 40 to 60, 40 to 70, and 40 to 80. And then the frequency, well, for the first one, it's just the 6. And then we've got another 16 to go into the next one, so that's 22. Then we've got another 28 to go into the next one, making that 50, and then another 10 to go into the last one, which makes that 60. Right. Okay, so now we've got our cumulative categories and we've got our cumulative frequency. So we can plot those points as we did in the previous example on this chart. Right. So now this chart, I mean, it starts at 0, but we're only interested from 40 because that's our lowest number. So and this little squiggle here on the bottom axis basically sort of says, well, we just squashed it in. It's just so we can show the vertical axis and the origin. But our interest is in 40 and above. Okay, so 40 to 50. So we're going up to 50 and we're going to mark in our 6. Uh, 40, we're going to 50, mark up 6. There we go. 60 is going to be 22, which is going to be there. 70 is going to be 50. And 80 is going to be 60. Right, so now we can draw a curve and we start at the bottom there. Okay. Not brilliant, but not too bad. Right, so now we've got all the same things again. But what is the median? Well, we've got 60. So if we're going to find the median, we basically want to read this across. Just do that. And then down, what's that? That looks about 63, I think. So we would say that the median equals 63. Now that's an estimate. It's an estimate because we don't actually have the numbers here anymore. They've kind of been categorized into these rows over here on the chart, and then that data is just kind of it's lost or ignored or whatever. So that's what we're this is what we've got available to us. So that's what we're estimating from. What else? Yeah. So what's the fuel consumption of the um, what fuel consumption can we expect from the top 10%? Well, the top 10%, we've got 60, so that's the top 6, isn't it? So that's going to be here. That's 54, I think, if we're coming from here. And if we follow that down there, we're going to get 72. Greater than or equal to, let's say, 72 miles per gallon. Over here it says work out the interquartile range. I don't think we need to do that because we did that in the previous example. Yeah, and so on. So what's the worst 20%? It's on the basis that lower fuel consumption is worse. Low 20%, so that would be 12, wouldn't it? So 12 is there, so that's going to give us this position here. Oops. And if we follow that down, we're going to get to about there. It looks like 55. And they're going to be less than 55 miles per gallon. So that's pretty well it. So we basically built this up from where we're actually given the line to a situation where we're given cumulative data by categories, and therefore we can still draw the line, but of course we're sort of approximating a lot of the values just because we know it's going to follow this kind of nice S-looking curve. And then we've looked at an example where we're not given cumulative, we're given the frequencies by each individual category, and we have got to derive the cumulative categories and the cumulative frequencies in here. It's not too difficult to do. Okay, and from that we can then draw it just simply by drawing these corners here. Okay, so that basically is what we do with cumulative frequency graphs or frequency charts in and how it all works. So hopefully that has been useful, and well, I'll see you next time.